Now, how does the automatic switch of an electric kettle help to conserve energy? So it automatically switches off when it reaches a certain temperature. So that means, because sometimes we do forget to turn off the button, so this will help us save energy. Now there are some ways in which you can save energy. So number one, you can switch off the lights and electrical appliances when they're not in use. Then you can use the energy saving bulbs rather than the incandescent light. So over here we have a filament, and when filament is heated, it produces light due to, so that means it basically produces a lot of heat energy compared to an energy saving bulb. That is why we call it energy saving, because over here we have a lot of heat produced, over here we have less heat produced. Then I practiced the 3 R's, which is reduce, reuse, and recycle. Then I walk, cycle, or take public transport. So this is basically going to prevent the burning of the fuel in the car. And then wear thicker clothing to keep yourself warm during winters, and then put on thinner clothing to keep yourself cool in summers. Then go to bed at dusk, and then wake up early in the morning. So it also prevents the turning on and turning off of light and the wastage of light. So what are renewable energy resources? Renewable energy resources are resources which will not run out in a long run. So for example, we have sun, we have wind, we have running water, we have tides, biomass, and geothermal. So over here, this is how sun energy is used, this is how wind energy is used, this is how water energy is used, this is how tide energy is used. Over here we have the biomass and then geothermal. Solar energy produces both heat and light. So we have three kinds of things which make use of solar energy. For example, when we have solar cells, light energy is used and converted into electrical energy. So for this, you have to remember that over here, only the light energy of the sun is being used. Used in solar powered calculators, satellites in outer space, and can be placed on the roofs for houses. Then we have solar heaters, which are black in color. Why? Because black color absorbs more heat energy. Then this heat energy is converted into electrical energy. So this makes use of the heat energy obtained from the sun. To heat water flowing in pipes under them, that's why we call them solar heaters. Then we have solar furnace. They're shiny and they're curved surfaces. So this helps to concentrate all the solar energy, all the heat energy to some small point, which becomes very hot. And then that, when it becomes too hot, it is able to heat the water, which then converts into a steam, and then steam turns on the turbine, which in turn turns on the generator to produce electricity. Now there are some disadvantages and advantages of solar energy. Number one, it's freely available and it does not pollute, but the disadvantages are harnessing or using it is not easy at all. And then sunshine depends upon weather, time of the day, seasons. Even in sunny countries, there may be a cloud cover, right? And then third is that the devices to make use of solar energy, they're very expensive, and then you need them in large numbers, and large areas of land are also used. Now, energy from living things is also called biomass. So biomass refers to plant materials, vegetation, waste from living things which are used as fuel. So for example, if I talk about biogas comes from animal and plant matter which rot in the absence of air, right? And this produces biogas, similar to natural gas. Why am I saying that is similar to natural gas? Because it also contains methane. And then it releases stored energy in the form of heat and light. If you talk about alcohol, then alcohol can be produced from a lot of foods such as sugarcane and corn, and by the process of fermentation. So this fuel can be used to run the motor vehicles. And then we have waste, animal manure, household waste, rubbish can all be buried in a hole underground and allowed to produce biogas. Now there are some advantages. Biogas will be there as long as there are living things, because we already discussed that this is all coming from the living things. The other is that, of course, it's a renewable resource. Now the disadvantages are that disadvantages that use of plant and animal for energy competes with its use for food, leading to increased prices. Since this food, this animal, and this, so basically plants and animals are also used as food as well. So when you're using it for energy as well, it basically creates a competition. Then energy from running water. So rivers flowing down from high mountains and waterfalls, they're able to turn the turbines due to its energy, due to the movement, and then these turbines in turn on the generators which produce electricity. Hydroelectric power stations, they need dams and valleys, which are so valleys are flooded with water to supply with a steady flow. Now, advantage is that no pollution or waste, but the disadvantage is number one, hydroelectric power station involves the construction of large dams and valleys. So these dams and valleys can destroy the wildlife and the habitats because obviously you have to clear the whole area. Then hilly areas and high and steady rainfall. So you need only these areas for them. Now, energy from wind. So for wind, we are going to use windmills, and the modern form of windmills are basically called wind turbines. They harness wind energy to produce electricity. So wind is able to turn the blades of a turbine, which is able to turn on the generator. The advantages are wind is free, and number two, that there is no pollution. The disadvantages are wind turbines stop working when wind stops blowing, of course, and you need them in large number. Then the location, you also need those locations. You need those locations which have steady and strong winds. Now let's talk about the energy which comes from waves. So waves are formed when wind blows across seas or oceans. So floating devices are used such as saltwater ducks. So what they do is that they make use of up and down movement of the waves, and there are a total of 25 ducts which are aligned, and their movement basically is able to drive the generator. Then we have a geothermal energy. Geo means earth, so and thermal means heat. So it is the energy. It is the heat energy which is inside the earth. So heat energy trapped inside the earth is called geothermal energy. This energy is released to the surface via volcanic eruptions or by hot springs. Hot water steam carrying geothermal energy comes up to the surface in some parts of the world, such as New Zealand and Iceland. So over here, hot water comes out, but in most of the areas, hot water does not come out. So for them, what we do is that geothermal power stations, they pump cold water down through very deep holes. So when they go deep down, from there they collect the water basically collects the geothermal energy, which basically results in the formation of steam that is able to turn the turbine and drive the generators. How do living things use energy? So living things use energy for important life processes. So for example, for breathing or for the organ activity, you need energy. So sun is the main source of energy, which gives the energy to the plant. The plant is able to convert that light energy into chemical energy through a process called photosynthesis. This energy stored in plant can also be used by animals. So indirectly, all the energy is coming from sun. Directly and indirectly, all the energy is coming from sun. So energy can be measured in kilocalories or kilojoules. So 1 kilocalorie, so kilo means 1,000. So 1 kilocalorie is 1,000 calories, 1 kilojoule is 1,000 joules. The joule is the SI unit of the energy. So kilocalorie or calorie is not the SI unit, SI is the standard international unit. Only joule is a standard international unit. This can come in the MCQ, of course. It is the energy needed to lift an apple of 100 gram or any object of 100 gram by 1 meter. Now, how much is 1 joule equal to? So how many calories is it equal to? So if a serving of cereal gives 100 kilocal or 420 kilojoules of energy, that means 100 kilocal is equal to 420 in case of this cereal. How many calories are there in 1 joule? So you're going to put them equal to one another. K and K cancels. So we have 100 cal and 420 joules. What I'm going to do is I'm going to take this over in the denominator. So 100 divided by 420 is equal to 1 joule.